All right, welcome back, guys. So, what we're going to look at next, we're going to look at problem solving with quadratics. All right, so there are a few little bits and pieces that we need to just settle first. Okay, so we can solve real world problems with quadratics, but we must consider the reasonableness of our solutions. Okay, so if we are finding, say, a length of a shape, of a side, of a pen, all right, it must be positive. You cannot have a negative length. So that means we reject any negative values we may find in our working out, all right? The second one is if we're finding the amount of people or the amount of animals, the answer must also be positive. Can't have a negative amount of people, a negative amount of animals, but it also must be an integer, so it must be a whole number because you cannot have 1/3 of a person, all right? We have to have whole people, all right? So they're the two sort of reasonableness assumptions we must consider every time we do a problem solving question, okay? So we can break down problem solving with quadratics into 4 different steps, all right? So step 1 is if the information is given in words, we need to translate that to algebraic terms, so in terms of x or whatever variable you want to deal with, and then we write out that equation, all right? Step 2, solving that equation for x with an appropriate method, so whatever you guys are comfortable using, whether it be factorization if you're dealing with quadratics, it could be anything, all right? So solving for x. Question 3, examine your solution for the reasonableness, all right? Especially keeping in mind these 2 things up here. And question 4, giving your answer in a sentence, actually answering that question, okay? So we're going to jump straight into an example, all right? So 720 meters of fencing is used to create 6 sheep yards as shown below. All right, so you're given this short side here is x, this longer length here is y. All right, so please note that these pens are actually identical. All right, so we can actually put that in here, so identical. That way we're not actually getting confused. All right, so because they're identical, we can say that all of these lengths without one line through them are x, and all these lengths with our 2 lines through them are y. So question A, explain why 9x plus 8y equals 720. As soon as you hear the word or read the word explain, you should be looking to explain that in words, okay? So the total sum of all lengths must equal the total fencing used. Therefore, 9 lots of length x and 8 lots of length y. So just going through counting how many x's we have, how many y's we have, and that sum must equal 720. Therefore, 9 lots of x plus 8 lots of y equals 720. Beautiful. Part B, show that the area function of each pen is 90x, take 9 on 8 times x squared. All right, so what we first need to look at is what the formula for the area of an individual pen is. All right, so area of a rectangle, length times width, so we've got x times y. But if we're looking down in our area function, we don't actually have any y variables in there. So we need to get that y in our area formula in terms of x, all right? So I'm going to start looking at the equation in part A, all right? And we're going to get that equation, so we're going to get y by itself in that equation, and that will be in terms of x, all right? So we pull that down here, take 9x from both sides, divide through by 8, and then we have y in terms of x, all right? So now we're looking at the area of one pen, x times y. We're just going to substitute in this thing we found just above into y. All right, we're just going to substitute that in for y. Multiply x by both terms, and we're left with 90x, take 9 on 8x squared, which is exactly what we wanted to show. All right, So that's all we needed to do for part B. Part C, find the dimensions of max area. All right, so the maximum area. When we're dealing with quadratics, the maximum or the minimum will occur at the vertex. We will have a maximum when we have a concave down quadratic. We know that our quadratic will be concave down if the a coefficient, so the coefficient of the x squared term, is a negative number. Looking at our quadratic here, x squared, locate that term, look at the coefficient. We've got -9 on 8. That means we have a concave down quadratic. That means we can find the vertex and we'll find the maximum coordinate. All right, so find the dimensions of the max area. Maximum occurs at the vertex of the quadratic. The x coordinate of that vertex is -b on 2a. Just substituting straight in our b value and our a value, you will find that x equals 40. All right, make sure you're just putting this straight into your calculator. All right, it just makes life so much easier when we do that. All right, and then because we have our x coordinate, we need to find our y coordinate. I'm going to substitute that y into our nice and easy equation that we rearranged in part B. All right, and it comes out that y equals 45. So therefore our max area dimensions are 40 meters by 45 meters, making sure that we are including units. All right. So if you're playing along with the Hazy textbook, making sure you're having a go at questions 2F, question 1, 2, 3, and 4, and chapter 2G, question 3, 5, 6, and 7. All right, so 2F is related to where functions meet, which is the previous video. 2G is related to problem solving with quadratics, which is this one. All right, see you guys next time.